This video is for Math 95 for the assignment on multiplying and dividing rational expressions. And remember, rational expressions are algebraic fractions. And so what we're going to be doing here is what we do when we multiply and divide fractions. So let's review that a little bit quickly. If we have something like 2/5 times, let's say 7/8, okay? Then we multiply straight across the top, get 14, multiply straight across the bottom, we get 40, and then we reduce it, so this would be 7/20, right? We divide both of those by 2 to get 7/20. Now frequently, what people do when multiplying fractions is rather than multiply first and then reduce, if we just multiply without getting our final answers, you can see the 2 on the top can cancel with the 8 on the bottom, and there's our 7/20, okay? It doesn't matter which way you do it, whether you reduce after you multiply or reduce before you multiply, but when it comes to algebraic fractions, the more you multiply things together, the harder it is to undo that. And so it's a really good idea to look to cancel first, okay, before you do all of that multiplying. Okay, so that is multiplying fractions. Dividing fractions, let's say we wanted to do 3/4 divided by, let's say 9/8, something along those lines. So the rule that is always taught for dividing fractions is to multiply by the reciprocal, or as a lot of people say in middle school and so forth, they say keep, change, flip, right? So we're going to multiply by the reciprocal here. Again, now this is just a multiplication problem, and we want to look to cancel if we can. Anything on the top can cancel anything on the bottom. So the 3 will cancel with the 9, the 4 will cancel with the 8. We'll end up with 2/3. Now, before I move on, I just want to talk a little bit about why do we multiply by the reciprocal? Why do we do keep, change, flip? Okay, so the issue here is really, so here's kind of a not very satisfying explanation, which is that division is defined as multiplication by the reciprocal. So if we're doing 10 divided by 5, we can calculate that as 10 times 1/5, and that'll give us 2 either way. But like I said, that's not really very satisfying. So let's look at it a little bit closer, and then come up with 2 different explanations, I think, that pretty clearly show why, if you want to divide by a fraction, you should multiply by its reciprocal. Okay, so first of all, the fraction bar means divided by. This number 3/4 is 3 divided by 4. And the reason why I say that is because if you want to write this division problem as a fraction, you can do that. This is 3/4 divided by 9/8. But the question is, what is this number? Okay, we already know it should come out to be 2/3. But let's look at it as what's called a complex fraction, where you have a fraction over a fraction. Now we can multiply this fraction by 1 and not change its value. And we do that frequently when we're adding and subtracting fractions, right? When we make common denominators, a lot of times we'll multiply by some form of 1, like 5/5, okay? Or 12/12, right? It's still 1. It's not going to change the value of this expression, okay? But it'll change the appearance and can make it into something simpler. So here's what I'm going to do. Those 2 examples I just gave won't help us very much in calculating this value. But here's something that will. What if I multiplied by 8/9 over 8/9? Now this is still 1, right? 8/9 over 8/9 is still equal to 1. So if we multiply it by the fraction, it's not going to change its value. But look at what happens on the bottom. 9/8 times 8/9, those are reciprocals. They cancel each other out. Up on top, here's our 3/4 times 8/9. that's going to give us the answer to this division problem. So there's one explanation of why do you multiply by the reciprocal, because it gives you the answer based on this scenario right here. Okay, so there's one explanation. Another one here is that when we're doing 10 divided by 5, we're looking for this number. We're looking for this answer that's going to have the property that when we multiply it by 5 is going to give us 10. Right? That's pretty straightforward. That's one of the definitions of division, is that your answer, when you multiply it by what you were dividing by, should give you what you were dividing into. Okay? And that's true for our answer of 2 here. 5 times 2 is 10. Therefore, 10 divided by 5 is 2. And so on. All right. So if we're doing 3/4 divided by 9/8, then our answer, which should be 2/3, but over here we don't really know that yet, is going to be what number do we multiply by 9/8 to get an answer of 3/4? Okay. Well, we can guess, but what I think is really helpful here is to build this number, right? The idea here is we've got an 8 on the bottom, but we want a 4. Well, let's cancel out that 8 on the bottom with an 8 on the top in our answer, and then replace it with a 4 on the bottom. Okay, so that'll give us a 4 on the bottom in our answer. Then we've got a 9 on the top, but we want a 3. So what we want to do is we're going to multiply by a 9 on the bottom, so it'll cancel that out, and then we're going to replace it with a 3 on the top. So this is our answer, okay? And this answer happens to be 3/4 times 8/9, just like we saw right here, okay? So there's two different explanations for why do we multiply by a reciprocal if we want to divide by a fraction. And so here's two valid ways to show that it's going to give us the calculation that we need to arrive at this answer right here. Okay, so there's our quick review of multiplying and dividing numerical fractions. So let's take a look at some of the problems on the assignment here. In problem 2, we're looking at y squared minus 7y plus 12 over y squared minus 4 times 2y plus 4 over y minus 3. So the fundamental idea for canceling, right, because really we need to cancel before we start to multiply. If you start multiplying all these things together, your answer won't be in lowest terms, and it'll be really hard to try to factor back out of the answers that you've gotten. Okay? So before we do any multiplying, we want to know what are the factors of all of these things. Well, for starters, that thing can't be factored. Y minus 3 is prime. It's just going to stay like that. Maybe there'll be another y minus 3 in here that we can cancel it with. We'll keep an eye out for that. Right here, you've got a common factor of 2, and that'll leave us with 2 times parentheses y plus 2. Down here, y squared minus 4, this is a difference of squares. So y plus 2 times y minus 2. And then this one is a trinomial, and we need factors of 12 that add up to 7. And that'll be 3 and 4. Y minus 3, y minus 4. So we'll get that negative 7 in the middle from the negative 4 and the negative 3. And we'll get the positive 12 on the end from negative 4 times negative 3. So now we've got everything factored. Now we want to look for something on the top that can cancel with something on the bottom, like this y minus 3 that I was saying before. So these two will cancel each other out. The y plus 2's will cancel each other out. And so on top we're left with 2 times y minus 4 on the top, y minus 2 on the bottom. We can't do any more canceling. These 2's will not cancel. This one is a factor. It could cancel another factor of 2. This 2 is not a factor. It's being subtracted, and so it can't be canceled. The only thing we could cancel it with would be another y minus 2, and we don't have that. So this is our answer right here in lowest terms. Okay, let's see here. Let's look at another one. Let's see here. Problem 4, I think, is pretty good. Let's take a look at that one. So, this is a squared minus 1, 2a squared plus 4a plus 2, and we're going to multiply a squared plus 2a plus 1 over a minus 1. All right. Well, again, this a minus 1, this is prime. It can't be factored. We're going to leave it alone. This one is a plus 1 times a plus 1. This one, this is a difference of squares, so it's a plus 1 times a minus 1. This one has a common factor of 2. So we're going to pull the 2 out, and then we'll have a squared plus 2a plus 1 there. And if we back up, I mean, we can factor this and cancel out both of these, but really what the easiest thing to do is just to cancel this with that. Okay, one on the bottom, one on the top. They cancel each other out and make 1. These 2 cancel. We're left with a plus 1 on top, and just that 2 on the bottom. Okay, so that's problem 4. Let's see here. Problem 6 is very much like problem 2. So let's take a look at problem 8. 8, we've got y squared minus 6y plus 8 over y squared minus 3y times y squared minus 9 over y minus 4. Okay, so very similar to what happened here, this y minus 4 is prime, can't be factored, we're just going to leave it alone. In the numerator, there's a difference of squares, so this is y plus 3 times y minus 3. This one is a trinomial. Factors of 8 that add up to 6 are 4 and 2, and we want them both negative, so the negative 4 and negative 2 make negative 6. And the negative 4 times negative 2 make positive 8. Now this one down here I left for last. Now notice that it's not trinomial. It doesn't have 3 pieces. It's not a difference of squares. It doesn't have that form. But it does have a y in both terms. So we can factor out that common factor of y and be left with y minus 3, which is nice because it'll cancel out with that y minus 3. And then the y minus 4's cancel each other out. So on top, we're left with y minus 2 times y plus 3. And on the bottom, just the y. And this can't cancel either one of those. These are trapped in the whole factor y plus 3. This one's trapped in the whole factor y minus 2. Okay, so those are the multiplying fractions problems. Let's take a look at a couple of dividing fractions. And the only difference here is that you just take the problem, multiply by the reciprocal, and then you're working a multiplication problem. So let's look at an example here. Let's see here. Problem 10. We've got n plus 2 squared over 4n squared minus 16 divided by 8 over 3n minus 6. So very first thing we're going to do here is rewrite this as a multiplication problem times 3n minus 6 on top, 8 on the bottom. Flip over what we're dividing by and multiply. All right, let's see. The 8's just going to stay there. Maybe we'll cancel it with something else on top. We'll have a 3 common factor of 3 here. We'll be left with n minus 2. Here, I mean, I'll write this out. We don't really need to do that, but it's n plus 2 times n plus 2. This one's a little bit tricky, Because as it sits, it's a difference of squares, but there's also a common factor of 4 in there. And after you pull that out, that allows you to factor this other difference of squares, and now you see these things are going to cancel. So one of these will cancel that one. This one's going to stay. The n minus 2's cancel each other out, so on the top we get left with 3 times n plus 2. And on the bottom it looks like all we get is 32, and so we just leave it like that. That's going to be the lowest terms for problem 10. Okay, let's see here. Yeah, problem 12 looks kind of interesting. Alright, problem 12, a squared minus 2a minus 8 over a squared minus 3a minus 10 divided by a minus 4 over a plus 2. Alright, immediately, the first thing we want to do, and often when I'm doing these problems myself, I don't even write this down. I just write times a plus 2 over a minus 4, just to save myself a little bit of time. So times a plus 2 on top, a minus 4 on the bottom. These are both prime. They can't be factored. We'll look and see if we've got common factors in these ones to cancel any of that. Okay? So these are both trinomials. They're both pretty straightforward. We're looking for factors of 8 that have a difference of 2. So a minus 4 times a plus 2. And this one, 5 and 2, so a minus 5, a plus 2. Now, see, just like in that last problem, we've got 2 of these on top, but only 1 on the bottom. So this will cancel out one of the a plus 2's. It doesn't matter which one, but it's only going to cancel out one of them. One of them is going to be left. Let's see, the a minus 4's cancel out. So on the top, we'll have an a plus 2. On the bottom, a minus 5. And then that's our answer in lowest terms. Okay, let's see here. Well, let's look at problem 16. Okay, so x squared minus 2x minus 3 over x squared plus 6x plus 5 divided by 6x minus 18 over x squared plus x. All right, so right away, first thing we want to do is rewrite this as a multiplication problem times x squared plus x on the top, 6x minus 18 on the bottom. All right, so now these all can be factored. All 4 of these can be factored. All right, this one has a common factor of 6. This one has a common factor of x. And after you factor out the x from here, you'll be left with a 1. Don't forget that. Okay? Over here, these are both trinomial. Here, let's see, we'll have x minus 3 times x plus 1. That'll give us the negative 2 in the middle. And this one, the factors of 5 that add up to 6, people often get confused by this. What you want is 5 and 1. 2 and 3 would add up to 5 and multiply to give you 6. Okay? That's the opposite of what we want. We want these to add up to 6 and multiply to give us 5. All right, let's see. So again, you've got 2 of these x plus 1's, but only 1 down here. So only one of them is going to cancel out. And then the x minus 3's will cancel out. So on top, we're left with x times x plus 1 over 6 times x plus 5. And that's it in lowest terms. So you can leave it like this. Sometimes people want to multiply it back through. There's nothing wrong with that. Okay? This is right, this is right. There are multiple correct answer forms for the correct answer. Okay, so that's multiplying and dividing rational expressions. It's all about finding the factors and looking to cancel the common factors before we end up multiplying. All right. As always, if you have any questions, please let me know. Thanks.